Chapter 2 Sets from Class 10 Andhra Pradesh and Telangana State Board Syllabus. What is a set? A set is a well-defined collection of objects. Let's say I ask you to write down set of first 5 even numbers. Let us say I ask you to write down set of first 5 even numbers. What are the first 5 even numbers? 2, 4, 6, 8 and 10. These are the first 5 even numbers. Now, these numbers are enclosed within the flower brackets. These are the flower brackets. These are the flower brackets. You enclose the numbers here in a set within the flower brackets, and a set is always denoted by uppercase letter. Let's say I write down A is a set of 2, 4, 6, 8, 10. Right. So a set is always denoted by an uppercase letter, and the numbers in a set are always enclosed between the flower brackets. The numbers that you see here in the set are known as elements of the set. What do we call them? We call them elements of the set. Can I say that, can I include the number 9 here in the set? Can I include the number 9 here in the set? No, I cannot, because 9 is an odd number. 9 is an odd number and not an even number. What is the rule that we are following here to fill in the elements in this set? The rule is we are going to write down a set of first 5 even numbers. The first 5 even numbers are 2, 4, 6, 8, 10. 9 and I cannot include in this set because 9 is not an even number. So you can say that the elements in a set follow, a set is a collection of things that follow a certain rule. A set is a collection of well-defined objects, or you can also say that a set is a collection of things that follow a certain rule. The rule that I am using here is I'm going to fill out only the first 5 even numbers. That's my rule for writing the elements of this set. Let's say I ask you to write down set of first 5 natural numbers. Let's say I ask you to write down set of first 5 natural numbers. What are the first 5 natural numbers? 1, 2, 3, 4, 5. These are the first 5 natural numbers, and we know that we enclose the elements of a set within the flower brackets, and we always denote a set by uppercase letter. Let's say I write down D is a set of 1, 2, 3, 4, 5. Now, there are two ways by which we can write down a set in two ways: roster form and set builder form. One is a roster form and the other is a set builder form. Here in set D, I have listed out the elements of the set. This is in the form of roster form. This is known as roster form. So in roster form, what do? We list out the elements of a set directly. Here also in set A also, I have listed out the elements that belong to set A. So this is nothing but roster form. Now what is set builder form? In set builder, to write a set in the form of to write down the set in a set builder form, we follow a particular syntax. Let's say I want to write down the set of first 5 natural numbers in set builder form. So I'll have to write it down like this. D is set of elements X such that X belongs to natural numbers and X is less than or equal to 5. So what I'm doing here, I'm saying that D is a set which contains elements X, and X, what is X? X here is a natural number, and up to how much? up to 5. X is less than or equal to 5. So what are the elements that I'm going to write here? 1, 2, 3, 4, 5. That's my set builder form. That is my roster form. Let us say, I believe you got the gist of it. So there's a particular syntax which we follow in writing a set builder form. In a set builder form, elements are not listed out directly here, and instead we write it this way. So I'm writing here D is set of elements X such that X belongs to natural numbers. We are writing natural numbers up to how much? Up to 5. So this thing, this D here, I'm representing it in a roster form. Now let's see here. What are the elements that you see in A? What are the elements that you see in this set A? We see that 2, 4, 6, 8 and 10. These are the elements of set A. So I can write it down like this. 2 belongs to set A. 2 belongs to set A. This symbol is read as belongs to. This symbol is read as belongs to. So 2 belongs to set A. 4 also belong to set A. 6 also belong to set A. 8 also belong to set A. D also belong to set A. Can I say that 5 belongs to set A? No, 5 does not belong to set A because 5 is not an element of set A. In such case, we write it down like this. This symbol is does not belong to. The order in which you write the sets is immaterial, which means, let's say I write down the set A as 1, 2, 3. If I write down the set A as 3, 1, 2 also, it doesn't matter. The order in which you write the elements doesn't matter in a set. And a set only contains distinct elements. It only contains distinct elements. Let's say for an example, I ask you to write down a set of letters forming the word school. Let's say I ask you to write down a set of all the letters being used in this word school. How do you write down the set? You need to write down the set like this. S C H O L. These are the letters that have been used in the word school. I'm not please observe, I'm not writing O twice here. I'm not writing O twice here because the elements in a set are distinct. They cannot be repeated. The elements in a set cannot be repeated. So I'm going to write S C H O. One more O is there. I'm not going to repeat O because I've already taken O here. And then I'm going to write L. So you have to remember that a set is a distinct collection of elements. A set has distinct elements. None of the elements in a set is repeated. Let us now learn about types of sets. Let's say I write down A is set of elements X. A is set of elements X such that X is a natural number smaller than 1. So A is a set of natural number smaller than 1. This I have written it in set builder form. So what can you tell me about the elements in set A? X is a natural number smaller than 1. Natural numbers start from 1, right? 1, 2, 3, 4, so on. These are natural numbers. Is there any natural number which is less than 1? No, there is no natural number less than 1. So this set will be empty. It will not contain any elements. Such a set is known as empty set. Such a set is known as empty set. A set which does not contain any elements in it is known as an empty set. It is also called as a null set, N-U-L-L, null set, or it is also known as void set. Let me give you one more example. Let's say I ask you to write down set of all odd numbers divisible by 2. So D is set of elements X such that X is an odd number divisible by 2. We know that 2 divides only even numbers. It cannot divide odd number. So there is no element that belongs to this set, because the number 2 does not divide any odd numbers. So this is also an example of an empty set. This is also an empty set. A set can be represented as a closed circle. Let's say I have a set S, and let us say the elements in set S are 1, 2, 3, 4. I can represent the set S as a closed circle. And what are the elements that you see in set S? This is my set S. And what are the elements that you see in set S? 1, 2, 3, 4. These are the elements that you see in set S. Let us say I write down one more element 5 outside the circle. Then what can I say about it? I can say that 1 belongs to set A, because 1 is inside the circle and the circle is the set. 1 belongs to S. What can you say about 5? 5 does not belong to set S, right? Because 5 is outside the circle. Let us learn about universal set and subsets. Universal sets are quite easy. Let us learn about universal set. Set of natural numbers. Natural numbers are 1, 2, 3, 4, so on. What are whole numbers? Whole numbers start from 0, right? 0, 1, 2, 3, so on. And what are integers? Integers, they contain both the negative numbers and they contain the positive numbers. So integers are from minus infinity to plus infinity. Integers are from minus infinity to plus infinity. So what do you observe here? You observe that the elements of set N, which is a set of natural numbers, are also the elements of set W, which is a set of whole numbers. In natural numbers, you have 1, 2, 3, 4, so on. Those numbers also belong to set W. Set N is a set of natural numbers. Set of natural numbers is denoted by the letter N. And here I can write down the set W. W is a set of whole numbers. So I can represent it in this way, because this rectangle that I drew here, this rectangle represents the set W. This rectangle represents the set W, which is a set of whole numbers, and this N that I wrote here, it represents set of natural numbers. Really, I have written here the set of natural numbers within the set of whole numbers, because all the natural numbers are also a part of whole numbers, right? The natural numbers that you see here, 1, 2, 3, 4, so on, these are also a part of whole numbers. Now, this set W will be known as a universal set. This set W is known as a universal set. And this set N is known as a subset. Let me do this here. Let's say I have drawn a rectangle here to represent integers, and you can see that the natural numbers and the whole numbers, they are a part of integers. So I can write it down here like this. This is a set of natural numbers and this is a set of whole numbers, right? That is the bigger circle is a set of whole numbers, the smaller circle is a set of natural numbers, and both the natural numbers and the whole numbers, they belong to the larger collection of numbers known as integers. Now this Z is known as universal set, and natural numbers, set of natural numbers and set of whole numbers are known as subsets of this universal set. Universal set is represented by mu like this, or you can also sometimes represent it like the uppercase U. So what is a subset? What is a subset? Let's say I have two sets. Set A contains the elements 1 and 2. Set B contains the elements 1, 2, 3. We see that all the elements of set A are also in set B. So if every element of A is an element of B, then A becomes subset of B. A becomes subset of B. That's a symbol that you use for subset. Okay. So A is a subset of B. Can I say that B is a subset of A? No, because there is an element 3 in B which does not belong to A. Right? So B cannot be a subset of A. A can be a subset of B because every element in set A is also an element of set B. That's the reason I can say that A is a subset of B. But I cannot say that B is a subset of A because there is an element 3 in the set B which is not an element of A. So B cannot be a subset of A in this case. Let us say I have a set. Let us say I have a set C with the elements 1, 2, 3. I have a set C with the elements 1, 2, 3. How many sets you can form by taking as many elements as you want from the set C? See, what I can do is I can take 1 and form a set. I can take 2 and form another set. I can take 3 and form another set. I took only single numbers. Now I'm going to take two numbers, 1 and 2. I can take 2 and 3. I can take 1 and 3. Then I can take all the three numbers from this, 1, 2, 3. So all these numbers, all these things that you see here, these are the sets that I can form from the set C. 1, set 1, set 2, set 3, set 1, 2, set 2, 3, set 1, 3, set 1, 2, 3. So these are the sets that I can form from the set C, which contains the elements 1, 2, 3. So how many sets I have formed? 1, 2, 3, 4, 5, 6, 7. I have formed a total of 7 sets. In general, the formula to find out how many subsets you can form from a given set, the formula is 2 power n. What is the formula? The formula is 2 power n. What is n here? N is the number of elements in the set. How many elements I have in this set? I have 3 elements in this set. So in place of n, I'm going to write down 3. 2 cube is how much? 2 into 2 into 2. 2 2s are 4, 2 4 2s are 8. So I'll get how many subsets? I'll get 8 subsets. But how many subsets I have got here? 1, 2, 3, 4, 5, 6, 7. I have got 7 subsets. Please remember, empty set is a set of every set. An empty set is represented like this, or a empty set is represented like this. And again, what is an empty set? Empty set is a set which does not contain any elements. Empty set is represented like this or like this. I cannot represent empty set like this because this would be wrong. This would this would convey the meaning that this set contains the element, this element. Likewise, I cannot represent an empty set like this. This would be wrong. This is not an empty set because it contains the element 0. So how many subsets I have formed here? I have formed 8 subsets. And what's the formula to find out how many subsets we can form using a particular set? The formula is 2 power n. What is n? N is nothing but the number of elements of that set. The number of elements of set C here is 3. So in place of n, I wrote 3. 2 cubed is 8. And we see that empty set is a subset of every set. Empty set is a subset of every set. So empty set is a subset of set C also. And what is 1, 2, 3 here? Set of 1, 2, 3. Set 1, 2, 3 is nothing but C itself. So you see here, every set is a subset of itself. Every set is a subset of itself. Let me just write it down in words. Every set is a subset of itself, and empty set is a subset of every set. Empty set is a subset of every set. The subsets that you see here, these 7 subsets are known as proper subsets. If you include the empty set, the number of improper subsets is 8. The number of proper subsets would be -1 because if you remove the empty set, you get the number of subsets as 7. These are the proper subsets, and 8. The number of improper subsets are 8. Properties of subsets. Let us say I have set A as 1, 2, 3 and set B as 1, 2, 3, 4 and set C as 1, 2, 3, 4, 5. What can I say? Can I say that A is a subset of B? Yes, I can, because every element of set A is also an element of set B. 1, 2, 3 you have in set A. 1, 2, 3 are also in set B. So A is a subset of B. Can I say that B is a subset of C? Yes, because all the elements of set B are also elements of set C. So B is also a subset of C. Can I say that A is a subset of C? Yes, I can, because every element of set A is also an element of set C. So I can say that A is a subset of C. So please remember, if A is a subset of B and in turn B is a subset of C, then A will be subset of C. Now let us see how to draw a Venn diagram. Venn diagram. We also call it as Venn Euler diagram. Let's say I have a universal set. I have told you that a universal set is denoted like this or like this. Let's say I have a universal set 1, 2, 3, so on till 10. And I have a set A which contains only the even numbers 2, 4, 6, 8 and 10. How do you represent this in the form of a Venn diagram or a Venn Euler diagram? You represent it like this. I've told you already, we draw a rectangle. We draw a rectangle. This rectangle represents the universal set. This rectangle represents the universal set, and set A I can write it down. I can write it down as a closed circle. I can draw it as a closed circle. So set A I can draw it as a closed circle. So this is my set A, And what are the elements that you see in set A? The elements in set A are 2, 4, 6, 8 and 10. These are the elements that you see in set A. What are the remaining elements? 1, 3, 5, 7, 9. You can write outside the circle A, because these elements 1, 5, 3, 7, 9, they do not belong to set A, but they belong to the universal set, right? So you can represent it like this. Let us now learn few basic operations on sets. Just the way you have addition, subtraction, multiplication, division operations in arithmetic, in the same way you have few operations in sets. Let us first learn union of sets. Let us say I have a set A which contains the elements 1 and 2, and I have a set B which contains the elements 3, 4. Then A union B, union is represented by the symbol U, union is represented by the symbol union. A union B is a set which contains all the elements of A and B. So what are the elements of A and B? 1, 2, 3, 4. These are all the elements in A and B. So union of A and B is the set which contains all of the elements of A and B, and union is represented like this by the symbol. Let me write down this thing in set builder form. So A union B is set of elements X such that X belongs to A or X belongs to B. So union contains all the elements from A and as well as B. Let us learn about one more operation on sets, which is intersection of sets. Let us say again I have two sets here, set A 1, 2, 3, and I have set B 1, 2, 3, 4. A intersection B, intersection is represented by this symbol. A intersection B is set of elements which are common to A and B. What are the elements in both A and B? 1 you have in A, 1 you have in B. 2 you have in A, 2 you have in B also. 3 you have in A, 3 you have in B also. So what are the elements that you see in set in A intersection B? In A intersection B you have the elements 1, 2, 3. The intersection of A and B is a set of all elements which are common to A and B. Intersection of set A and B is a set of all elements which are common to A and B. So A intersection B contains the elements that belong to both set A and set B. Let me write this thing down here in set builder form. We can write it this way. A intersection B is set of elements X such that X belongs to A and at the same time X should also belong to B. For an example, 1 belongs to A, 1 also belongs to B. That's the reason I included the element 1 in the set of A intersection B. So intersection is nothing but common, the elements which are common to both the sets. Intersection of sets contains the elements which are common to both the sets. Now let us learn about disjoint sets. Let us learn about disjoint sets. Let us say I have a set A here which contains the elements 1 and 2, and I have a set B which contains the elements 3 and 5. Please remember the elements in a set are separated by the comma symbol, So I have a set A which contains elements 1 and 2. I have a set B which contains the elements 3 and 5. Do you see any of the elements common from A and B? Are there any elements common in A and also in B? No, there are no elements which are common in A and B. So A intersection B would be empty. A intersection B is empty. Such sets are known as disjoint sets. So these are disjoint sets. A and B are disjoint sets because they don't have any elements in common. Let us now learn about difference of sets. Difference of sets. Let us say I have set A which contains the elements 1, 2, 3, and I have set B which contains elements 2, 3, 5. What is A minus B? A minus B is difference of A and B set. A minus B, it will contain elements which are in A but not in B. What are the elements that you see in A but not in B? Okay, one is an element in A which is not in B. 2 is in B, so I'm not going to write it. 3 is also in B, so I'm not going to write it. So what is A minus B here? A minus B is 1. In simple terms, you can calculate A minus B just like this. What is set A? 1, 2, 3 minus what is set B? 2, 3, 5. Just cancel out the common elements. 2 and 2 I'm cancelling it out. 3 and 3 I'm cancelling it out. What are the elements in set A? What are the remaining elements in set A? 1. 1 is the only element remaining in set A. So this is my A minus B. This is A minus B. So A minus B is set of all elements that belongs to A but does not belong to B. In the same way, let's say I try to find out B minus A. How do I find out B minus A? What is B here? B is 2, 3, 5 minus what is A here? 1, 2, 3. Cancel out the common elements 2 and 2, 3 and 3. What are the elements remaining in first set? 5. So B minus A is 5. Please observe A minus B is never equal to B minus A. A minus B is never equal to B minus A. Let me draw the difference of sets in the form of a Venn diagram. In Venn diagram, I told you that we have a rectangle and let's say I have two sets here. Set A, this is my set A, and let us say I have another set here, set B. What should be A minus B? A minus B is set of elements that belong to A but does not belong to B, right? So I can shade this region here, just this region, because this is a part of A but not part of B. In the same way, let's say if I wanted to draw a Venn diagram for B minus A, for B minus A, how do I draw it? I draw it like this. I'll shade the region which belongs to B but does not belong to A. Belongs to B but does not belong to A. How do we write difference of sets? Difference of sets in set builder form. We can write it like this. A minus B contains elements X such that X belongs to A and X does not belong to B. Let us now learn about equal sets. Two sets A and B are equal if every element of A belongs to B and every element of B belongs to A. Let's say I have a set A which contains elements 1 and 2, and then I have another set B which contains elements 1 and 2. I see that every element of A here is also an element of B. So I can write it down like this. A is a subset of B. A is a subset of B because every element of set A is also an element of B. Can I also say that B is a subset of A? Yes, because every element of B is also an element of A. When A is a subset of B and B is a subset of A, we say that A is equal to B. So these two are equal sets. A and B in this case are equal sets. Two sets are equal if two sets A and B are equal if every element of A is also an element of B and every element of B is also an element of A. Now let us learn about finite sets. Let's say I write it down like this. A is P, a set of elements P, Q, R, S. How many elements are there in the set A? How many elements do you see in set A? 1, 2, 3, 4. So you can obviously count the elements in set A. The number of elements in set A are 4. So this is known as a finite set. This is known as a finite set. A set is called finite set if it is possible to express the number of elements of it in definite whole number. I can obviously count the number of elements in set A. The number of elements in set A is 4. So this is an example of a finite set. Let's say I give you an example like this. D is set of elements X such that X is a multiple of 7. What are the multiples of 7? 7, 14, 21, 28, 35, so on. The list goes on. The list goes on. It doesn't end. So this is known as an infinite set. This is the set D in this case is an infinite set because the number of elements that belong to the set D are infinite, are unlimited, right? What is cardinal number of a set? Cardinal number of a set. Let us say I have a set A which contains the elements 1, 2, 3, 4. How many elements are in set A? 1, 2, 3, 4. 4 elements are in set A. So number of elements in set A is 4. And so we say that the cardinal number of set A is 4. The cardinal number of set A is represented like this. N of A. Similarly, cardinal number of set B would be represented like this. N of B.